Good day, everyone. You are welcome to Gala Science Academy. Our today's topic in chemistry class is organic chemistry. So, if you look at organic chemistry, is one of the branch of chemistry which the course code for the university beginner, they used to call it what? CHM 102. It simply means what? It's a vital topic in the what? In the chemistry. And it's also the simplest topic we have in what? In chemistry. So before I move into the organic chemistry, I would like to explain two things. The organic compound and inorganic what? Compound. Or in the past, scientists, they classified all compound we have in chemistry into two. We have what we call what? Organic compound, and we also have what? Inorganic what? Compounds. I said in the past, in older days, scientists are classify all the compounds we have in chemistry into what? Into two. Compounds into what? Into two. We have organic and what? Inorganic. What are they used to what? To classify the compound into two. Based on their what? On their source. That's what? They classify all the compounds into two based on their what? On their source, where they what? They get them. So that is, they call this organic what? Compound. That is a compound that's derived or obtained from living organism. So what? Organic compound is a compound that is what? We obtain from what? From living organism. What are these living organisms? The living organism we have here, it may be what? Plant and what? Animal. So in the early days, they believe that what? We can get organic compound from what? From living organism, either plant or what? Or animal. And we can never synthesize or produce organic compounds in laboratory. Their belief is what? The only means that we can use to what? To get organic compound is from living organism, which is plant or what? Or animal. And in this source too, we have carbohydrates. We have what? Carbohydrates. We have protein. We have lipid. You know, all these three compounds, they are organic what? Compounds. So the only days they believe that what? We can never prepare these three compounds from laboratory except by what? Get on what? Plant and what? An animal. This inorganic compound, they believe that what? Inorganic compound is a compound that obtained from non-living thing or non-living organism. What inorganic compound is a compound that what we can obtain from non-living what organism, and then we can prepare them in what in laboratory. Example of this inorganic compound, we have what we call what table salts. So that is their what their belief in olden days. As a result of this, at the end of this belief that what organic compound can obtain from living organism and non-inorganic compound can obtain from what from non-living organism. That is what the belief of scientists in olden days. Because of this belief, in 1809, one scientist came. His name is his name is Basilius. So Basilius came in what? In 18 what? 1809. In 18 what? 09. With a what? A particular theory called vital force theory. A vital force what? Theory. Basilius came in what? In 18 what? 09. And with own what? Theory called what? Vital force theory. We state that what? Organic compounds can be what? Can be produced from living organism, which is what? Plants or what? Or animal. That is what? The Basilius theory in 18 what? Oh, no. Yes, let me start from here. In 18 what? Yes, what is the theory? Vital. Let's start from what? The Basilius what? Theory. His theory is what? Vital force. Theory what? Theory. And that's what? In 1809, the what? Basilius presented a vital force theory. So this theory was what? Whereby what? By Basilius in 1809. The theory states that this what? Theory states that organic compounds, organic what? Compound, compound are synthesized by living organism. By living what? Organism. What are the living organisms? Plants and what? Animal. So the vital theory was promoted in 1809 by the what? Basilius. We state that what? Organic compound are synthesized by living what? Organism. Abi? Yes, let me continue. And continue. And It cannot be prepared. It can not be prepared in a laboratory. Cannot be prepared in the what? In laboratory. That is what? Berzelius theory, which is also known as what? A vital force theory. The theory says that what? We can never get organic compounds from laboratory. The only way we can get organic compound is from a living organism. Good. Yes, for example, for what? For example, according to this theory, according to what? To this what? Theory, we have carbohydrates, hydrates like sucrose. The general formula for sucrose is C12, yes, H22, O11. Sucrose is only synthesized, only synthesized by plants. Synthesized by what? By plants, and we cannot prepare it, we cannot prepare them in laboratory. That is what he said. All carbohydrates, maybe sucrose, maltose, lactose, said we can prepare them by what? You can get them from plants. You can never prepare carbohydrates from laboratory, according to the what? A vital force theory, which proposed by Berzelius in 1809. Please note it. The second theory, the second one, sorry, not theory, example of vital theory. Secondly, he said protein can only be synthesized. Protein can only be synthesized by animal. By what? Animal. E.g., like what? Egg in chicken or meat. So protein can only be synthesized by what? By animal. We cannot what? We cannot prepare them in a laboratory. So if you ask, which theory states that what? The protein can only be prepared or can only be synthesized from animal is called vital force theory, which is what proposed by Berzelius in 1809. So, in olden days, they believe that what? Organic compounds, we can get them from what? From a living organism. Who said so? Berzelius, from his theory called vital force theory. But you couldn't believe in 1828, 1828, which is what? 19 years after. In 18 what? 1820 what? 28, which is what? In 19 years what? After, another person that came is a German scientist in 18 what? 29, which is what? 19 years after Berzelius. Another person that came is a what? A German scientist, and his name is Friedrich Wöhler. His name is what? Friedrich Wöhler. The Friedrich Wöhler that is came 19 years after what? The fighter theory of Berzelius came and what? And broke the fighter force theory. Friedrich Wöhler came in 1829 and broke the what? The fighter force theory. We say that what? I, Friedrich Wöhler, that came from the German, I can synthesize organic compound in laboratory by eating ammonium cyanide. We eat ammonium cyanide and it's giving what? Urea. In eating ammonium what? Ammonium cyanide. Eating ammonium cyanide, this, when it eat it, it will give you what? You what? Urea. This urea is the first organic compound that we produce in laboratory. The Friedrich Wöhler came in 1829, which broke the what? This fighter theory that it is a lie. I, a German scientist called Friedrich Wöhler, I can synthesize among what? Urea, which is organic compound excreted by living organism, by animal. I can prepare urea from laboratory by eating ammonium what? Cyanide. And it's giving what? Urea. This urea is the first organic compound produced in laboratory by Friedrich Wöhler. So this Friedrich Wöhler is also known as what? The father of organic chemistry. This is the history of organic what? Chemistry. You know, our topic is organic chemistry. So I'm trying to what? To explain the historical development of organic chemistry from 1809 by what? Berzelius up to the what? A German scientist which break the fighter force theory by prepare the first organic compound in laboratory called urea from ammonium cyanide. So let's go. In what? In 1828, a German, a what? German scientist, six, a German scientist called Friedrich Wöhler. Spelling Friedrich. Who what? Wöhler broke the fighter force theory. Broke what? Fighter, let me continue it. Was what? Theory by Prepare first organic compound. First what? Organic compound. The first organic compound. First organic compound called what? Urea in laboratory. So you may ask in a multiple choice question that the first person that produced organic compound in laboratory is called what? Friedrich Euler, or the person that broke a vital force theory is Friedrich Euler, and is a German scientist in 1828, which produced the first organic compound called what? Urea in laboratory. In laboratory, compound in what? In laboratory. Yes, by so what? It took ammonium, ammonium cyanide, take ammonium cyanide after eating, afterwards, eating, it converted into, or it converted to urea. Let's see it now. We have ammonium cyanide, CNO minus. This formula is known as what? Ammonium what? Ammonium cyanide. So the vesicular take what? Ammonium cyanide, it eats it, it apply it. This symbol represents it in chemistry to the ammonium cyanide. It later discovered that is what? It give in what? Urea of NH, H, H, NH, H. So this is the structural formula for what? For urea, and it form urea, which is what? The first organic compound produced from the what? From laboratory. And this is the equation that is break the vital force theory. And this experiment that the Friedrich Euler did in 1829, it made him to become the father of what? Organic chemistry. Can I say that what? Friedrich Euler is the what? Father of what? Friedrich the what? Euler is the father of organic chemistry. Please note it. Who is the father of organic chemistry? Friedrich Euler. Like Gideon Mendel is the father of genetics in what? In biology. We had Robert Hooke is the father of cell in biology, and the Aristotle is the father of what? Biology, or the father of what? Of zoology. So That is all about what? Historical development of what? Of organic what? Chemistry. Let us now define organic what? Chemistry. What is organic what? Chemistry. Can I say what? Organic chemistry is the branch of chemistry that deal with study of carbon and its compound, exception of what? CO2, CO, CO3 minus, because they are inorganic what? Compound. So you can say what? Organic what? Compound. Organic chemistry. What? Organic chemistry divine is a or is the branch of chemistry which deal with study of carbon. Deal with study of what? Of carbon and its compounds, except CO, carbon dioxide, CO2, carbon, carbon monoxide, carbon 2 oxide, and carbon 4 oxide, and CO3 2 minus. So the modern definition for organic chemistry is a branch of chemistry that deal with study of carbon and its compound, exception of what? One, carbon dioxide, carbon monoxide, and CO3 or 2 minus salts. Yes, at this junction, I used to ask myself a question here. What is the question? Out of almost 118 elements we have in periodic table, why is it that what the organic chemistry just deal with the study of carbon and its element alone, or and its compound alone? Out of what 118 elements we have in periodic table, but organic chemistry is deal with what? The study of carbon and its compound alone. Why? I keep asking myself that question. Why is it that what organic chemistry is the study of carbon and its compound out of that element? So the answer for my question is the next topic now, called uniqueness of what? Of carbon, or we can also call it what? Unique properties of what? Of carbon. Unique what? Properties of what? Of carbon. The answer for my question is this. Because out of the 108 elements we have, 118 elements we have in periodic table, is the only carbon that is have these 4 or 5 unique properties, which is not common in any other element. So the ability of carbon to undergo the 4 or 5, the uniqueness properties, is to make him what? Ideal among the other elements we have in periodic table, and it will make him to what? To be studied in organic chemistry. What are the properties? Number 1 is tetravalency. the what? Tetra what? Valency of carbon. Do you know the meaning of this tetravalency? It's very easy. Tetra means 4. The word tetra means what? 4. We have what? Tetra simply means what? 4. Where we have tri simply means what? 3. Where di is what? 2. Mono is what? 1. So the tetra here means what? 4. And the valency means what? Atomo electron. We have done it in chemical bonding. So the valence means what? Atomo shell. This is what? Tetra 4. Simply means what? When carbon is what? Is bond with any other element, this tetravalency means what? 4 bonds must attach to carbon. Whenever a carbon is what? Is bond with any other element or with carbon himself, must have how many bonds? 4. Denote it. Tetravalency simply means this. This is what? Carbon. It will have what? 4 bonds in it what? 4 bonds must what? Must attach to it. So whenever we are drawing the structure of carbon, is the most 4 bond must what? Attach to it. That is tetra what? Tetravalency. You can draw it in this form, or if you like, you can have it in what? In this form. All I know is what? 4 bond must what? Attach to what? To carbon after bonding. Good. So this is the only carbon that have what? This ability or this property. The second property is what? The ability of carbon to unite with another carbon by a single or double or triple bond. Now what? Ability of what? Of carbon to what? Unite with another what? Carbon. Ability of carbon to unite with what? Another what? Carbon. To unite with another what? Carbon. Yes. By a single or double or triple bond. See, out of the 180 elements we have periodic table, is the only carbon also have this property. With carbon, it can form a single bond. Carbon with carbon can form a single bond. Carbon with carbon can form a double bond. Carbon with carbon can form a triple bond. Other elements cannot. That is here now, we can have a carbon with carbon. How many bonds do we have here? A single bond. This carbon can also form with carbon. How many bonds? Double bond. Carbon with carbon, you can also have what? How many bonds here? Triple bond. So carbon with carbon can form a single bond with another carbon, double bond, with another carbon, triple bond. These properties make carbon to what? To be unique. So because of all these properties, it will make organic chemistry to be the chemistry of carbon. Once again, here I said in bonding, how many bonds must attach to carbon? 4. Here I put 1 here, Abi. This one remains 3. 1, 2, 3. Here, 1, 2, 3. This one is a balance. This one, we have carbon, 2 bonds attached to them now, and I said it's 4. So you put 2 here, 1, 2, 3, 4. This one is balanced. Here, 1, 2, 3, 4. This one is balanced. Here now, we have 1, 2, 3. This carbon, remain what? 1. So I said, even in organic chemistry, whenever you are doing the structure of carbon, is a must. 4 bonds must attach to carbon, tetravalency. Carbon can form a double bond, a single bond, and triple bond with another carbon. Other elements cannot. The next one is what? Ability of what? Of carbon to unite with another what? Element. Another what? Element by a single or double or triple bond. See, this same carbon can form a what? A double bond. Look at carbon can form a single bond with hydrogen. This is carbon. The same carbon can form carbon with double bond with what? Oxygen. This same carbon can also form what? Carbon with triple bond with what? Nitrogen. Can you see it now? Carbon, the bond between carbon and hydrogen is what? Is 1. Carbon with oxygen is what? Is 2. Nitrogen is what? Is 3. This only carbon have this property that can unite with other elements with single bond or double bond or triple bond. But this structure is not balanced now. I said 4 bonds must attach to carbon. I be now from here. How many do you have here? 1. Remain 3. Here, how many do you have here? Remain 2. Here, remain 1. So the next, this is 3 Abi. The next unique property of carbon is the carbon can also unite with what? With another what? Carbon. Another carbon or other element to form a stable ring compound. The carbon can unite with another carbon or another element to form a stable ring. A stable what? Ring called what? Compound. Let us look at that one. That will be 1, 2, 3. Ability of carbon to form a stable no ability of carbon to unite with another carbon to unite with carbon or other element to form a stable to form a what? A stable ring compound is the only carbon that also undergo this what? This property. Let's check it. Carbon can bond with another carbon to have this shape. The same carbon can bond with another carbon to bond with another carbon to bond with another carbon to have what? This shape. This same carbon can bond with what? Another carbon, with another carbon, carbon to have this what? This shape. This same carbon can bond with another carbon. We have zero here, oxygen, carbon, 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 this is oxygen. I said can unite with carbon other elements to form a what? A ring. The same carbon can also unite with another carbon, another carbon, another carbon, yeah, another carbon, another what? Carbon to have what? This. You can see that what? The carbon form a ring table compound. Out of 118 elements we have in the periodic table, the only carbon have all this property. So the tendency of carbon to undergo all this property, it make him unique among other elements in periodic table, and it will make him to be studied in organic chemistry. You may ask, why is it that organic chemistry is the study of carbon and its compounds? Why? Because of the uniqueness of the carbon. What are the unique properties of the carbon? Tetravalency, unite with carbon, single bond, double bond, triple bond, carbon with other elements, single bond, double bond, triple bond, ability to form a ring compound. And the last one is what? Ability of carbon to unite with another carbon or other elements to form a ring, to form a long chain, which is called catenation. Let's check it. The next one is what? Ability of carbon to to unite with carbon or other elements. Sorry, ability of carbon to unite with carbon to form a long chain, which is called catenation. What is catenation? The term catenation is what? Ability of carbon to form a long chain. So the only carbon can form a long what? Chain. Like this, it can unite with carbon, 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 with carbon. See, this carbon can form a million what? Can form a chain of thousands or tens of what? Of millions. The tendency of carbon to form a long chain like this, we call it what? Catenation. So there are many, but these are the what? The common and necessary, the uniqueness properties of what? Of carbon that make carbon to be unique, and then we study carbon in what? In organic chemistry. So the next thing that we are going to treat now is what? What is organic compound? I've explained organic compound from the beginning of the what? Of the class. So after I explain the organic compound, in the organic compound, they are the compounds that is obtained from a living organism, and there is a compound that is contain carbon bond, and it dey exist in a family of homologous series. So that is after that I will explain what we call homologous series. The homologous series exists or occur in a functional group. After that, I will explain the functional groups.